In this video, we're going to go over the problem on page 638 in your workbook. Let's take a quick look at it before I turn you loose on it. So here's the problem. So we've got regions R and S, which are formed by the graphs of f of x and g of x. I've got them labeled here. Let me start off by giving you a question that they don't ask. If I just asked you for the region between these curves, and I'll go ahead and spot you that this intersection point here is 1, 1/4. But if I wanted you to calculate the area between these two curves, your initial thought might be, yeah, I know how to do this. I'm going to take the integral from 0 to 1, because those are my bounds, of f of x minus g of x dx. So I'm just going to calculate that, and that's going to give me the sum of those two areas. And here's the question I have for you. Why is this wrong? Why is that not the solution to the question? All right, so pause the video, think about that, and also take your best shot at solving these questions. And you'll definitely want to use your calculator for this. All right, so pause the video now and give that your best shot. All right, so what I'm going to do is I'm going to solve this on the Inspire, except this time I'm going to use the calculator side of things instead of the graph side of things. So you'll get just a different view of the Inspire's features. The first thing you'll notice that I did is I defined these two functions, just so it'll be easier for me to calculate that. If you don't know how to define functions, you can just go to Menu, Actions, and then Define. And you can either define a variable to equal some number, or you can define a function just the way I did here. All right, so the first thing we want to do is we want to identify the points of intersection of f of x and g of x. All right, so the first thing I'm going to do is I want to solve f of x is equal to g of x. I need to put in the variable I want to solve for. And then you can also put in two extra numbers here to give you a left bound and a right bound of the function. Since I told you that the other intersection point is at 1, 0.25, we know that the one between R and S is going to be somewhere between 0 and 1. So maybe I'll say 0.1 and 0.9. And this tells me that that x value is 0.178218. 0.178. And then to calculate what the value of that is, I'll just put in 178. All right, and so that's my y value. And we'll notice that I'd get the same answer if I put in that. See, a little different, but that's because I just rounded that. All right, so let me clear this out just so that we delete. All right, so 1.78. All right, so the first question that they ask us after that is to find the area of region R. Okay, so to do that, we're going to calculate a numerical integral, and the left bound is going to be 0. The right bound is going to be that 0.178 that we just put in. And what is the function I'm going to put in here? Well, it's going to be g of x minus f of x dx. All right, and so the area of that is 0.065 to 3 decimal places. All right, now the next question they ask is, what is the area of region S? So region S is bounded by those two functions, except it's on the other side. And here's what's different about that. Here's why I can't just put in that same function. And this is the answer to the question of why the integral from 0 to 1 doesn't give you the sum of those two functions. And what we need to do here is we need, once again, Menu, Calculus, Numerical Integral. We want the integral from 0.178 to 1, but this time over the region S, it's f of x minus g of x, because now f of x is the top function. All right, so the area of region S is 0.410 or so. And just to drive home that idea, if I calculate the sum of those two areas is around 0.47, but if I calculate the area from 0 to 1, I get 0.34. And the reason for that is that this first area is g of x minus f of x, and the second one is f of x minus g of x. If I'm calculating it like this, then it's calculating region R like it's a negative area instead of a positive area. And so it's subtracting the 0.06 from this when I wanted it to be adding. So that just gives you a little bit of a clue that you need to be careful when you calculate the area between two curves. If there are multiple regions involved, you want to be careful about which is the top function and which is the bottom function over each one of those subregions. All right, the last question we have here, and I'm going to pop back to the document camera for this, is that we want to find the area of the unshaded region bounded by the graphs of f, g, and the x-axis. So we want the area of this shape right here. Okay? So if you haven't thought about that, think about it now. You might need to do some extra calculations before you're able to figure this out. But I want to break this up into a couple of different regions. All right. So I just broke this into 3 regions, and this area is the integral from 0 to 0.178, which was that intersection point of f of x dx. And then I want to add this area, which is the integral from 0.178 to 1, but this time it's g of x dx. And what is that last area? Well, it's the definite integral. Once again, it's the definite integral of f of x, and it goes from 1 to, I don't know which value it is. I need to figure out what the x value of that is. Okay, so with that in mind, let's pop back to the calculator. All right, and so the first thing I want to do is I want to figure out what is the 0 of f of x that's a little bit beyond there. So once again, I'm going to, I want to solve f of x is equal to 0. I want to solve that for x, and I want the value that's somewhere between 1 and, let's say, 2. All right, and so it tells me that the x coordinate of that 0 is 1.08. All right, and so that is going to give me everything that I need to know. So I'm going to put in calculus, a numerical integral. I want the definite integral from 0 to 178 of f of x dx. And I want to add the definite integral from 0.178 to 1 of g of x dx. And now I want to add menu 4, 2, the definite integral from 1 to 1.08, once again, f of x dx. So it'll do all of that math for me, and the grand total of that area down there is 0.486257. All right, so there was a lot of thinking that needed to be done on that problem. But it was all in the capacity of the calculator. But remember, whenever we're using the calculator, we're the ones who've got to think about which buttons to press in order to get the answer that we want. Calculators are really good about doing what they're told, but they're not super good at being, solving a problem that you didn't want solved. You need to make sure that you're the one who's asking good questions. And that's why they don't mind having calculator questions on tests like the AP exam, because they're going to make sure that they're going to ask questions where they're testing your ability to put the right buttons on the calculator.